In today's video, we're diving into the top 21 programming languages, starting from the most beginner-friendly high-level languages to the least beginner-friendly low-level languages that run directly on bare metal. Whether you're looking forward to building a web application, process massive datasets, or write an operating system, understanding where each language sits on the spectrum is crucial. Let's get started. Let's start off with the internet's inseparable web twins, HTML and CSS. Separate them, and your entire web page break apart faster than a Jenga tower. HTML was created by
Tim Berners-Lee.
It's the markup language that gives your web page its skeleton, the structure, the meaning, and the semantic blocks. CSS, introduced by
Hakan William Lai
in 1996, is the stylist responsible for giving HTML a glow up. Together, we're fully supported natively by every browser on Earth, which is why the web even exists, and are great for rapid prototyping and iteration. But their biggest weakness is that they have zero execution logic. They can't do math, loops, or state management. Without JavaScript stepping in, HTML and CSS are like a smartphone in its case without the battery. Just a static web page with no life or logic. Here's a tiny demo. So let's break down the syntax. Here is the CSS part of the code. It's responsible for setting the text color and font style. And this H1 is an HTML heading tag. It's used for opening and ending the heading, and whatever text is in between it is what appears on the page, which in this case is hello world. Next up, Python, the snake in your nightmare that pulled up the Uno reverse card on you and said relax, coding doesn't have to hurt. Conceived by
Guido van Rossum
in 1991, Python was intentionally designed for readability. It's so clean and expressive that half the time it feels like you're writing English instead of code. Python's greatest strength is its development speed. Thanks to massive libraries like NumPy, Pandas, and TensorFlow, it dominates artificial intelligence, machine learning, and data science. But because Python is dynamically typed and interpreted, it runs significantly slower than compiled languages and handles memory less efficiently. That's why you'll never see Python powering a game engine or an operating system. It simply wasn't built for raw performance. Here's a tiny demo. So, let's break down the syntax. Print is a built-in function that shows information on the screen, and we add quotations in the parentheses to display our desired text, which in this case is hello world. Moving on to SQL. SQL is that neighbor who knows exactly where all your data lives, but it won't tell you anything unless you ask the perfect question. The structured query language, invented by
Donald Chamberlain and Raymond Boyce
at IBM in the 1970s, is declarative, meaning you don't tell it how to find data, you just describe what you want, and SQL does the rest. It's insanely efficient at filtering, sorting, and processing millions of rows across relational databases like PostgreSQL and MySQL. But its limitation is huge. SQL is strictly domain-specific. It can't build apps, can't handle unstructured data like videos, and absolutely refuses to do anything outside the world of structured tables. Here's a tiny demo. So let's break down the syntax. The command select hello world AS greeting tells the database to return the text hello world, label it as greeting. SQL doesn't print text like other languages. Instead, it retrieves data by following your query instructions. Lua. Think of Lua like a GPU bracket, small and simple, but preventing the entire system from sagging under its own weight. Lua is the tiny, lightweight language created in 1993 at PUC Rio. It was designed to be embedded inside larger languages like C and C++, which is why it powers Roblox, World of Warcraft add-ons, and tons of embedded hardware systems. It's fast, portable, and perfect for game scripting, but its minimalist nature is also its weakness. Lua's standard library is so bare bones that you rely heavily on the host application for anything complex. Here's a tiny demo. So, let's break down the syntax. The function print hello world displays the text inside the quotation marks. This works similarly to Python's print function, making Lua's output very easy to understand. Ruby, the language that chose dynamic elegance and developer happiness over raw machine efficiency. Released in 1995 by
Yukihiro Matsumoto.
Ruby blends the best parts of Perl, Smalltalk, and Lisp into a highly expressive object-oriented playground. Ruby's biggest claim to fame is Ruby on Rails, which powered early giants like Twitter, GitHub, and Airbnb. Its strength is how human-readable and beautiful the code is. Everything feels like a polished sentence, but the elegance comes at a cost. Ruby's abstraction layers make it slower and more memory-hungry than compiled frameworks. Here's a tiny demo. So let's break down the syntax. The command puts hello world prints the text and automatically adds a new line afterward. Ruby's puts is its simple way of sending text to the screen, similar to how print in Python works. PHP. PHP is the eccentric grandparent of the internet, who is somehow still powering 80% of the world's websites. Created by
Rasmus Lerdorf.
in 1995, it started as a simple toolset for tracking web traffic, but evolved into the backbone of platforms like WordPress, Wikipedia, and early versions of Facebook. PHP is incredibly easy to deploy and integrates seamlessly with databases. But because it evolved rapidly and without strict oversight, PHP ended up with inconsistent naming conventions and historical quirks that developers still roast today. Here's a tiny demo. So let's break down the syntax. The statement echo hello world outputs the text to the web page. PHP uses echo to send information directly to the browser. JavaScript. JavaScript is what happens when a developer is given 10 days to build a language, and somehow it ends up running the modern world. Created by
Brendan Eich.
in 1995, JavaScript started as a simple browser scripting tool, but exploded into a full-stack powerhouse thanks to Node.js, React, and countless frameworks. It's dynamic, synchronous, and completely ubiquitous. But its rushed creation left behind infamous quirks like silent type coercion and confusing scoping. Here's a tiny demo. So let's break down the syntax. The function console.log hello world prints the message to the browser's console. This is JavaScript's built-in way of showing information while debugging. Next up, TypeScript. TypeScript is the product of JavaScript going to the gym. Released by Microsoft in 2012, it adds static typing, structure, and sanity to the chaos. A strict syntactical superset of JavaScript, meaning it adds types but still compiles down into plain JS. Its strength is catching catastrophic bugs before your code ever ships, but its downside is that browsers can't run TypeScript natively. Everything must compile back to JavaScript first. Here's a tiny demo. So let's break down the syntax. The line console.log hello world prints the message just like JavaScript. TypeScript adds type checking behind the scenes, but the output remains the same. Swift. Swift is the language Apple created because they looked at Objective-C and said developers shouldn't have to write ancient hieroglyphics. Unveiled in 2014, Swift is fast, safe, and heavily relies on type inference to keep syntax clean. It's perfect for iOS, macOS, watchOS, and tvOS development. But despite being open source, Swift is still overwhelmingly tied to Apple's ecosystem and their IDE Xcode platform. Here's a tiny demo. So let's break down the syntax. The function print hello world displays the text in Xcode's console. Swift's print function is clean and straightforward, similar to Python's. Kotlin. Think of it as Java's younger, cooler sibling. Developed by JetBrains in 2011 and officially backed by Google, it's modern, statically typed, and fully interoperable with Java. Its biggest strength is built-in null safety, which eliminates tons of runtime crashes. But because it often compiles back to Java bytecode, it still inherits some of Java's runtime overhead. Here's a tiny demo. So let's break down the syntax. The command println hello world prints the message and moves to a new line. Kotlin uses this simple function to show text on the screen. Next up, Java. Think of it as the corporate executive of programming languages, professional and structured. Released by Sun Microsystems in 1995 under
James Gosling.
Java is stable, scalable, and supported by huge frameworks like Spring. But Java is notoriously verbose, requiring lots of boilerplates even for simple tasks. Here's a tiny demo. So let's break down the syntax. The method called system.out.println hello world prints the message to the console, and the public static void main marks the starting point of the program. Java requires a structure to run any code. Dart. Dart is the programming language equivalent of an arrow hitting 3 targets at once. Released by Google in 2011, it was originally meant to replace JavaScript, but found its true calling power Flutter. Flutter is Google's cross-platform UI toolkit. It supports both GIT for rapid development and AOT for fast production builds. But outside the Flutter ecosystem, Dart's adoption is still heavily limited. Here's a tiny demo. So let's break down the syntax. The function print hello world displays the text, and void main tells Dart where the program begins. Dart uses a simple print function similar to many modern languages. R. R, created in 1993 by
Ross E. Harker and Robert Gentleman.
It's built specifically for statistical computing and shines in data analysis and visualization. But it's not a general-purpose language. It runs slowly for everyday tasks and is poorly suited for production web services. Here's a tiny demo. So let's break down the syntax. The command print hello world shows the text, and R adds 1 to indicate the first item in a list. This formatting reflects R's focus on data and statistical output. Go. Go, a language so stripped down that by the time you finish saying Go, you've learned half the syntax. Released by Google in 2009 and designed by
Robert Griesemer, Rob Pike, and Ken Thompson.
It's the modern cloud infrastructure standard, powering Docker and Kubernetes. It compiles fast and handles currency effortlessly with with Go routines, but its minimalism means developers sometimes miss advanced features found in other languages. Here's a tiny demo. So let's break down the syntax. The function fmt.println hello world prints the message, while package main marks the file as an executable program, and import fmt loads Go's formatting tools. Go keeps its printing system simple, but requires those setup lines to function properly. Julia. Julia is the language where your code looks like an unsolvable mathematical problem that somehow outputs speeds similar to C. Released in 2012, it was created by
Jeff Bezanson, Stefan Karpinski, Viral B. Shah, and Alan Edelman
at MIT. It was designed for high-performance numerical computing, combining Python's ease with speeds of C. Its main downside is the first plot problem, where initial completion causes noticeable startup delays and high memory usage. Here's a tiny demo. So let's break down the syntax. The command println hello world prints the message and adds a new line. Julia uses this clean syntax while compiling the code behind the scenes for speed. Rust. And no, not the rusty card, but instead the programming language released by Mozilla in 2010. Rust achieves C-level performance without a garbage collector thanks to its strict ownership system. It guarantees memory safety and prevents databases before your code even runs. But it has a steep learning curve, and the compiler will fight you until you learn its rules. Here's a tiny demo. So let's break down the syntax. The macro println hello world prints the message, and the exclamation mark indicates that println is a macro rather than a regular function. Rust uses macros to handle formatted outputs safely and efficiently. Carbon. Carbon is like spending hours at your desk with great enthusiasm and energy, only to look down and realize you've written one word. Introduced by Google in 2022, it's meant to be a successor to C++, offering modern syntax and safer defaults while staying fully interoperable with existing C++ code bases. But it's heavily experimental and nowhere near production ready. Here's a tiny demo. So let's break down the syntax. The function print hello world plays the text, and fnmain i32 defines the program's entry point and return type. Carbon's syntax is designed to feel familiar to C++ developers while being cleaner. Next up, C. C is the only language where forgetting to clean up after yourself won't just make a mess. It will literally cause your entire operating system to have an existential crisis. Developed by
Dennis Ritchie
at Bell Labs in 1972, it offers raw speed, tiny runtime footprint, and absolute hardware control. But it lacks modern abstractions and requires manual memory management, making it easy to introduce catastrophic bugs. Here's a tiny demo. So let's break down the syntax. The function printf hello world prints the text, and hashtag include studio.h loads the standard input-output library. C uses this formatting function to control how text appears on the screen. Next up, C++ is like launching a rocket that flies 1 foot, misfires, and explodes because it forgot a semicolon. Created by
Björn Stroustrup
in 1983, it expands C with classes and high-level paradigms while staying close to the middle. It powers AAA games, browsers, and high-frequency trading. But it's extremely complex, slow to compile, and still relies on manual memory management. Here's a tiny demo. So let's break down the syntax. The statement stdcout hello world sends the text to the console, and hashtag include IOStream provides access to C++ input/output tools. C++ uses stream operators to handle printed output. Finally, C#. C# is essentially Microsoft copying Java's homework, changing a few variable names so the teacher wouldn't notice, and somehow getting better. Launched by Microsoft in 2000 under
Anders Heilsberg.
It's elegant, component-oriented, and the backbone of the Unity game engine. It has a rich standard library and great tooling, which historically tied directly to Windows execution, but modern .NET development has made it cross-platform. Here's a tiny demo. So let's break down the syntax. The method console.writeLine hello world prints the message with a new line, and using system imports the basic tools needed for the program. C# uses this clean and readable structure for console output. And finally, assembly. Assembly is the final boss of software engineering. The exact moment where a developer's soul leaves their body, replacing their smile with a permanent, dreadful stare. Originating in the late 1940s, built by early pioneers such as
Kathleen Booth, David Wheeler, Morris Wilks, and Stanley Gill.
Assembly is a low-level abstraction, just one step above raw binary. There is no variables or classes here, only direct manipulation of CPU registries and memory addresses. It provides flawless hardware optimization. Providing even basic logic requires deep architectural knowledge and is completely non-portable between processor families. Here's a tiny demo. And each line of the code moves data into CPU registers and instructs the processor to print the message. Assembly performs these operations manually, giving you direct controls over the hardware without any shortcuts. And that concludes our tour across the ecosystem of the top 21 programming languages, from the fundamental layouts of HTML to the absolute bare metal control of assembly. Every single tool on this list was engineered to solve a specific problem in computer science. There is no single best language, only the right tool for the architecture you're building. So to recap, use HTML, CSS, JavaScript, and TypeScript for web frontends. Lean on Java, C#, PHP, and Ruby for enterprise backends. For mobile applications, use Swift, Kotlin, and Dart. For data sciences, rely on Python, SQL, R, and Julia. For high performance, rely on Go, Rust, Carbon, C, C++, and Assembly. If you found this breakdown valuable, tell me down in the comments which language was your favorite and why. Thanks for watching, and I'll see you in the next one.